Bueno,
Alright,
vamos a continuar
let's pick up
ahora
now where we
allí donde
left off in the
dejamos en
previous
el video
video.
anterior.
Since I didn't show you, you may be wondering how I inserted all these fields for each item in the collection. Actually, it was very simple. When I went to create the grid, I'll do it with another one, and I chose the variable collection SDT, it automatically asks which of the elements I want to insert in the layout. See what happens if I choose these, for example. There we see that it's the same as the grid above. I'm going to delete this one. And if I select one of the elements, we can see that it's identified in this way. Note that I set the label position to none so that the label of the variable, which of course is read-only, does not appear. And also, let's see how I applied to all the texts the typography classes that we had entered some time ago in the preparation stage, remember? I filtered by card attraction, and in the card attraction region, we see these three classes, which are precisely the ones we apply to these elements. Here, the rating, here H1. In addition, I had to download this image from Figma and enter it in the KB because I had missed it in the preparation stage. And what I did was to insert these two images. We can do that in our other grid, the one that we want to implement with attributes instead of the SDT variable to see it, but this is very simple. So really, the work that we have left to do here at the layout level, which in this grid at the moment is universal, is to place all these controls properly to be able to implement the card, where we're going to overlay controls so that we already know that this table should actually be a canvas. But see how I structured inside my other grid the internal elements of the canvas. As for the loose image, note that it has this class that I especially created inside a specific DSO to design the specifics of this panel. That's why I named it the same as the panel, attractions. Here I have the class. We did this before, remember? For the header. But I didn't want to use its same class here in case I need to differentiate them later. We must set its absolute positioning, and, as we can see, it'll occupy 100% of the width and height of the canvas, reaching the edges and the deepest layer. Next, we see that I placed all the other elements in another table, with 2 rows and 3 columns. In the first row, I placed the icon, a space, and the name of the country. And in the second row, another table, which expands between the 3 columns of the containing table. It's aligned horizontally to the left and vertically down in relation to the cell that contains it and which corresponds to the second row of this table. We can see that I gave it 100% height because I entered 18 dips for the first row that I extracted from here. And let's see these 24 dips at the top of the canvas, these 30 on the left, and this gap of 17 dips between the icon, which is almost 10 dips wide, and the text Italy, and that they're centered vertically, as we can also see. So I left 10 dips for the icon column, 17 for space, and the third column to expand to the remaining 100%. But with the condition that this variable is horizontally aligned to the left, and both controls vertically in the middle. The table's inside the canvas, so it was placed relative to its borders. We just saw that it started at 24 dips from the top and 30 from the left. And let's see where these 32 from the bottom and these 25 from the right come from. We see them there. We round them up, We set the table with Z order 1 so that it's above the image. And now let's analyze this subtable. It has two columns, the one on the right of 105 dips, which is the maximum space that can occupy the width of this other table, and the one on the left, which will contain this variable, which has a space of 100% of the remaining width of this table to occupy. And what's the width of this table? 100% of its container, which is the entire row 2. Since it adds up the three columns, because it expands into three columns, it's clearly 100% of the width of the table. What is it then? The one that results from subtracting from the width of the canvas the left and right borders. I could continue analyzing each value that I gave to each property, but as it's more of the same and I don't want to bore you, let's leave it here. You can investigate all this in detail in the XPZ file that will be available. As I've been repeating from the beginning, there's almost never only one way to implement things. The advantage of having placed this and this control in a table is that I model the alignment to the left in an optimal way. Imagine I need to change the distance from the left border of the canvas, for example. I do it only once for the table if I have these controls either individually or in separate tables. I'll have to make the change for each one. The same goes for controls that we know must be aligned horizontally in some way, such as these. When there's an obvious structure in the design that interrelates the controls, then it's convenient to use tables in the appropriate varieties, such as flex for some cases, of course. Now I want to tell you how I analyze the differences between the small cards and the large cards. We knew that one was 260 dips high, and the other was 560 dips high. The difference of 300 dips is given only by this vertical space. That is, to convert a large card into a small one, all that's needed is to remove this space in the middle of 300 dips. Note that the distance between this element and this one is 80 dips here, while here it's almost 380. That is, 300 is the difference between one and the other. So I could focus first on modeling the small card as if it were the default one, and when I finished it, I implemented the large one. And we could do the same very quickly with our grid with attributes. Here I set the dimensions of the canvas. And then I start to model the table controls to place our image and attribute controls inside the tables that we had identified. Finally, I set this as the second row of the main table, and I make it expand in the three columns. Well, and the rest, basically, is to copy the properties that we had in attractions copy to this other one. I start to do it quickly, but I leave it as a task for you. Actually, it would have been convenient to copy the whole canvas and there replace the variables with attributes. Here we have the small card ready. I'm going to rename the canvas to attraction card, as in the other grid. And I'm going to rename this item layout to small. It'll be the default. And now I'm going to add another item layout, which I'll call large. It's initialized with the layout of the only one that was there. So it'll have exactly the same controls with the same values for the properties. As we already saw, the only difference between the small and large layout will be their height. Here, it'll be 560 dips. Let's analyze why. Just by doing this, there will be 300 more dips between the row of this table and the table of row 2. The borders of the containing table are set at these distances, top and bottom. The height is relative to the height of the canvas, which is what varies between the two layouts. But in addition, this table has a fixed height and is aligned vertically down, so it'll always be on the bottom edge. And therefore, the space left to complete 100% of the height of the row where the table is located is the one that'll cause the difference of 300 dips between one case and the other. We still have to copy what we did here to load each item in the grid with the corresponding layout. I copy both events. I paste them. I remove this, that doesn't go here. In the refresh, I only leave to set the counter to 0. I change the name of the grid to the one I've been using, Grid Attractions. I define the variables in this panel, and this is perfect. But note that if I end the name of the grid with a period, I find the eligible property, and there I complete it. Let's place the exclamation mark so that neither this text nor the other is translated. Before running it, note that the grid is a standard grid. If I run, this is what I see. I'll modify the grid to be flex. I set the column direction, wrap, justify the content according to the beginning, that is to say, to the top edge, the alignment of the items relative to the other axis, the horizontal one, also according to the beginning, that is to say, to the left edge, and this one too. We execute. We see that in each column there's only one card instead of two. Why? It has to do with this scroll bar, which occupies a separate space in desktop. This space must be taken into account. So for example, if in the grid we have an item that's 100 pixels high and another one that's 200 pixels high, for both to fit the height of the grid cannot be 300. It has to be greater because it must take into account the height of the scroll bar, which is outside. In our case, the height we gave to the grid row is 829 dips, and the two cards added together give 820, 260 plus 560. Evidently, the 9 extra dips are not enough to place the scroll bar, and that's why it's not possible to fit 2 cards per column. In this F12, I only have web debugging enabled for desktop, and not web for mobile devices. See that if I turn on mobile debugging, now both cards fit, because in the mobile browser, the scroll bar is placed on top. However, the screens we're designing will only be run on desktop, so we need to solve that scenario. Clearly, we need to increase the row's height. When we reach this value, 837, the 2 cards per column are displayed. And of course, if we continue to increase it, we see how the scroll bar is separating. So we needed to assign it 17 dips because the 2 cards added up to 820. We need 17 dips for that scroll bar. In addition, we need to leave the empty space between cards. Note that in the Figma design, the cards have a margin on the right of a bit more than 11 pixels, and below of almost 11. So, to all the cards in the grid, we could assign a margin of 11 at the end in both directions. We can assign a class to the grid in which we define, through the GX properties, GX grid even row class and GX grid odd row class, classes that give a style to the grid cell when it's an even item or odd item. This row here in the name must be understood as the position of the item. That is, Beyond how the rendered items are displayed on the screen, something that among other things depends on the type of grid, conceptually, every grid is an ordered list of items. So there's the first, the second, the third one, and so on. Then we must see how this order is rendered, as I said. The property GXGridEvenRowClass will apply to all the items that occupy an even position in that list, and odd to those that occupy an odd position. It allows this discrimination, let's say this alternation between odd and even. In our case, to all the items we want to apply the same class, which I'll call AttractionsGridCell. Also, I will define these two properties, margin inline end of 11 pixels and margin block end, that is, in the other direction, also of 11 pixels. And then I simply set the class for the odd and even items to be the same. And it's this one. What I have to do now is to calculate the height I have to give to the grid row. It'll be 11 by 2 due to the block end margin of the two cards, plus the 820 height of the two cards added together, plus the 17 of the scroll bar. So I go to Attractions, and in the second row, I place this value. Let's execute. Perfect. What if we don't want the bottom margin for the lower cards? The lower cards will be the odd cards if we start counting at 0. 0, 1, 2, 3, 4, 5, and so on. Then we can do this. We differentiate two classes, one for the even and one for the odd cards, and we remove the bottom margin from the odd ones. And now we subtract these 11 from the row height, and we execute. Okay, we see that the bottom margin is no longer there. In my solution, let's do the same with the grid associated with the STT. Now let's pay attention to this tap event that we had associated with the canvas of each item to invoke the attraction panel by passing it the ID of the attraction. This is not the best solution because we've programmed the tap for the control named attraction card, which actually corresponds to two different canvases, that of the small layout and that of the large layout. In fact, I had to explicitly give it the same name, so be careful. The grid has a predefined event that corresponds to a tap or click on any of its items. It corresponds to this property, default action. Let's use this other solution in our attraction panel. What I do is to create a new user event, which will correspond to the default action on the items of the layout. I give it a name. Now let's see that there's a set of properties that allow defining a certain behavior of the grid. For example, whether to allow selecting grid items, what type of selection, and so on. Here's the event, and what we'll have to do is to invoke the attraction panel, passing it the attraction identifier, which in this case will be in the attraction ID attribute. But do we have the attribute loaded in the grid item so that we can pass it to this other panel once the grid is loaded? Initially, it seems that we don't. So if we want to make sure that this value is available, we can insert the attribute, set it as invisible, and also set that no space is reserved for it in the layout when it's invisible, precisely. Well, this applies to the large layout. We'll have to do the same for the small one. And this can start to bother us, these duplications, and we can be tempted to create a stencil for these cards. If we don't do it, then I have to copy this control and paste it here. If we run now, okay, Let's try another one. The large one, perfect. Now let's see if it was necessary to set the invisible attribute. Let's remove it, and remove it from the large layout as well. We run it, but before it ends, let's look at the navigation list. In the data provider corresponding to the grid, it informs us that it's bringing attraction ID. It's going to store it internally. We didn't have to do what we did. And let's finish checking. Okay, it is indeed passing the attraction ID because it counts on it, and Genexus did it automatically. I'm telling you this because in web panels, this is not the case. Something that may catch our attention is that here the text is not split into lines, as it was in the solution with the STT. There are breaks when the text doesn't fit in the space. When using the attribute, its content is displayed as it's loaded in the database. In my solution, instead, I process what I return to the STT for this field in this way. To adapt my solution, I would have to place a variable here instead of the attribute. This variable should be based on the attribute. For example, by calling it the same, it'll automatically offer me to base it on the attribute of the same name. And I would have to do the same for the other layout item. And in the load event, I should assign this value to the variable. If we now execute, all the texts look as we wanted. To address accessibility, we would have to make each card show as its name the name of the attraction. For that, we should place region here and an accessible name, not custom, but the one based on a control. But for now, we can only base on text block control and not on a text variable. So in fact, instead of the attraction name variable, we should place a text block and make this assignment to the caption property. So as not to make this too long, I'll leave it for you to do it. The grid also has accessibility properties. I hadn't mentioned it explicitly, so I do it now. I created a DSO per object whose UI I've worked with so far. Therefore, I have that of the master panel, of attraction, of attractions, which was the one where we did all this, the base one. And in travel agency, which will be the parent of all, of course I had to include all the others. Finally, we could have used a stencil so as not to duplicate the layout of the cards, since the only difference between the small and large items was the height of the canvas and nothing else. Then we could have inserted a stencil control for each layout item, and that way, everything related to the card layout is solved only once. For example, if we want to change the distance of this table in relation to the top, we do it here, and it'll automatically affect both layout items. However, there are some clarifications to be made in the solution, which are related to how to work with relative values for the internal table of the grid, which we can't go into right now. And that's why I won't dwell on the solution. However, I'll leave an XPZ file for you to explore all of this.